Okay, this is task 2. We are doing our best to model and explain the energy conversions among elastic energy, kinetic, and gravitational energy when a ball bounces. Check out that video from the Slow-Mo guys. This one is a video of them wrapping rubber bands around a watermelon and what happens. So to review our key terms, elastic energy is associated with deformation of an object by compressing it or stretching it. So rubber band you would stretch, ball you would compress. All right, and its ability to return to its original shape. And that whole idea will come up in the next task and in the weeks coming. Deformation, the action of changing in shape when adding pressure to the object. All right, and elasticity is the ability of an object or material to resume its normal shape after being stretched or compressed. So you watch the slow-mo bounce, and I'm going to show you a video of a ball bouncing. You made a prediction. All right, so now we're kind of reviewing what an energy transfer diagram is. So you have this one on your screen. This is the one I did last week with the flashcards. So we had just gravitational and kinetic energy here. I dropped the flashcards. We started with all gravitational, me just holding on to it. Potential, has the potential to move. And we dropped it, and as it was falling, it was gaining, increasing or gaining in kinetic energy and decreasing in gravitational energy up until we reached this point. And if you remember what this is called, it's that split second before it hits the ground. It's called impact speed. At any time, no matter how fast it's going, that split second before whatever it is hits the ground is going to be the most kinetic energy that that object will have. So it'll be all kinetic energy. So here we have a bouncing ball. All right, so I'm going to insert my video, or I'm going to try to, at this point, so you see the ball bouncing, and then I'm going to go over this. Okay, so I'll see you in a few.
Go.
All right, so we saw a ball bounce, and what we're really focusing on is that releasing of the ball, the bouncing of the ball, and then it's going back up to its new maximum elevation. Obviously, you know, it's not just one and done. There's several bounces along the way, but we'll get to what's happening there probably in a few weeks. Okay, so I kind of just followed the one in your book. My past one I made gravitational energy just blank. The one in your book or on the screen has gravitational energy like a polka dot, kinetic energy filled in, and elastic energies with stripes. All right, so this first point here, which I didn't label them, is all gravitational, so it's all polka dotted. It has the potential to move. I'm holding on to the ball, and then I release it. All right, so the second one along the way, it's gaining kinetic energy, gaining even more kinetic energy, really decreasing in that gravitational energy. And then 4, we have that split second before the ball reaches the ground, so impact speed. 4, actually this is 4.1, 4.2, 4.3, 4.4, and then 4.5. That's really kind of our focus. All right, so I'm going to leave it blank. 5, it's going back up into the air. So it still has a lot of kinetic energy, but it's starting to decrease in that kinetic energy, and there's a little gravitational energy starting to come up because it is gaining elevation. And same here, we still have quite a bit of kinetic, but it's increasing in gravitational energy. And then we have this new highest elevation point, and that is going to be all gravitational energy. And you can imagine at this point, if it has all gravitational energy again, what's its next step? It's probably going to continue to fall again, right? But we'll focus on that later. All right, so here, this is kind of our focus area, 4.1 to 4.5. So if this is 4.1, this is 4.5, and this is impact speed. That's kind of my hint to you, impact speed. And then we have, if we look at the center one here, if we look at the ball, that is the maximum point that it is squished. So, which energy do you think it has there? And then I believe that's 4.3, 4.4, and 4.2 still have some squish, but not as much as 4.3. So that's kind of my hint to you when you are putting your circles in their correct spots as to where you think they should go. Good luck.